Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be going over salts. So what is a salt? Well, a salt is an ionic compound usually formed when an acid and a base react with each other. And so this is, for example, we have NaOH, that's our strong base, and HCl, strong acid, acid base react together, form water, and here we have our ionic compound NaCl. And here we have ammonium hydroxide reacting with hydrochloric acid, again, forming water and this ammonium chloride salt. So these are the salts that are produced. They're ionic compounds. So how do salts behave when you put them in water? Well, they're going to dissociate for the most part, right? So we know that, they dissolve, the ions dissociate, and that means that the ions are going to separate. We'll talk about later about how much they're going to separate, how much they dissolve, but typically they're going to dissolve. And so, for example, our NaCl is going to dissolve into separated sodium ions and chloride ions, and your ammonium chloride is going to separate into ammonium ions and chloride ions. So, how do these ions behave once they are dissociated? Well, they can sometimes react with water. So, for example, if you take ammonium ion can react with water. It can donate one of its protons to water to form the hydronium ion, and then you're left with ammonia. So, this can happen to some of the ions that are in your salt. So the ion, in order to do that, has to be strong enough for that to happen. And I'll talk more about what it means to be strong enough for an ion to react with water. So let's talk about what happens or what's the result of when these ions react with water. Okay, so what is the result when ions actually do react with water? Well, once the ion reacts with water, it can make the salt solution either acidic, basic, or neutral. So if we look at these three examples, here we have our ammonium ion. The ammonium ion can react with water by donating a proton, and it's going to make the hydronium ion plus ammonia. And so because this ion here is acting as an acid, it's creating hydronium ion, therefore the solution becomes acidic. So what about our carbonate ion? So the carbonate ion will react with water. It will pull a hydrogen off and it will create HCO3 minus and plus your hydroxide ion. So this ion is going to cause the solution to be basic. So it's reacting with water to produce your hydroxide ion. And then if you have chloride ion, that's not going to react with water because chloride ion is not strong enough to react with water. And I'll talk more about what strong enough is just in a moment. So let's talk about how do we determine or what it means for something or an ion to be strong enough to react with water. So, how do you know if the ion is strong enough to react with water? Well, you have to think about the properties of the acids and bases that the ion came from. So, if you have a strong acid and the ion came from a strong acid, then that ion is going to be a weaker conjugate base. So, being a weaker conjugate base means that it's not going to react with water. If you have a weak acid, then that conjugate, the ion that comes from the weak acid is going to be a stronger conjugate base compared to the weak acid, and therefore the stronger conjugate base, the ion is going to act as a stronger conjugate base, and it will react with water to get back that hydrogen. If you have a strong base, then that strong base is going to result in a weaker conjugate acid. That's your counter ion, the ion that is produced by the strong base. And so then that weaker conjugate acid is not going to react with water because it's weaker than the strong base from which it came. And then the weak base here, if you have a weak base, well, that's going to produce an ion that is going to be a stronger conjugate acid compared to the weak base it came from, and therefore it will react with water to give that proton to water. So it's going to act as a strong or stronger conjugate acid. And so you can think about in terms of strong and weak acid, right? So strong and weak acids are strong because they dissociate or ionize completely in water. So they don't want to be together. So that ion, the counter ion, right, that releases, for example, if you have HCl and HCl completely dissociates in water, well, the chloride ion is that weaker conjugate base, but it's so weak that it's not really going to want to pick up the hydrogen. That's why it is completely dissociated in water, right? So it's not going to be strong enough to pick up a hydrogen from water, so it's going to not react. Same thing with a strong base, so completely dissociated in water. Weak acids and weak bases are the opposite. They hardly dissociate in water. Why? Because the parts of the ion, the parts of the molecule, right? So for example, if you have a weak acid HA, or let's say sulfurous acid H2SO3 or something along those lines, then the weak acid is going to stay for the most part in this whole form H2SO3. It's not going to ionize very much at all. Very little is it going to ionize. Why? Because the counter ion, the conjugate the conjugate acid is stronger than the weak base, or the weak acid in my example is weaker than the stronger conjugate base. So the conjugate base is going to want the to hold on to that hydrogen more than the weak acid wants to give it off. So if it dissociates or if it ionizes, then it's more likely to react with water to pull off a hydrogen or to give a hydrogen to water. Okay, so why does this happen? Why does a weak acid or a strong acid turn into a weak conjugate base and vice versa? Let's talk about that a little bit more. Okay, so why does strong turn into weak and vice versa? Well, you got to think about where the equilibrium lies for the original acid or base. This is what I was referring to earlier. So if you have, like, say, a strong acid, here you have a strong acid here, right? So the strong acid HCl wants to ionize, right? It's going to mostly ionize so that the equilibrium lies far to the right, so that most of what you have in solution is going to be the H plus and Cl minus ions. It is practically speaking going to be 100% ionized, and so pretty much all you're going to have in solution is the H plus Cl minus. You might have a very, very tiny fraction of HCl. So given that this is what HCl wants to do, be broken into its ions, then do you think chloride ion is going to go around taking hydrogen or H plus from water to make Cl? No, that's not going to happen. So that's what we mean by Cl being too weak to or not strong enough to take a hydrogen from water to make HCl, because HCl does not want to be formed. It wants to be ionized completely in water. So let's talk about some steps that you can follow in order to determine whether the ions in your salt is going to be reacting with water, and how so. Okay, let's talk about the steps on how to predict the pH of a salt solution. So the first step is to identify the acid or base that each salt comes from, that each salt ion comes from. So Your salt is going to be made up of two ions, a positive ion and a negative ion. So you got to look to where those ions would come from. What kind of acid, what kind of base would those ions come from? So for example, if you're looking at chloride ion, well, that's a negative ion, so it would be coming from an acid with an H plus. So you add an H plus to it and you see that it's HCl, which is a strong acid, right? Or if you have something like, NH4 plus. So NH4 plus, you lose that H plus and it becomes ammonium. So it comes from the base ammonium. So you look to see what acid or base each ion in your salt came from. To determine if the ions will react with water. So again, if it's from a strong acid or from a strong base, that ion will not react with water because it's not strong enough and to take away or give a hydrogen to water. So you're going to end up with a neutral solution. If it's from a weak acid or base, then it will react with water because the equilibrium lies far to the reactant side, which is on the left side. And so it's going to react with water to get back to that reactant form. So it's either going to form a basic or acidic solution. Number three, if it does react with the water, you need to identify whether it's going to form an acid or a base, right? So here's that table again that I showed you before. So if the ion comes from a strong acid, then it's going to be a weaker conjugate base. So that means that it's not going to react with water and it's going to be a neutral solution. If your acid, if the ion came from a weak acid, it's going to form a stronger conjugate base. So the ion would be a stronger conjugate base. And so that's going to react as a base in water. So it's going to react with water and then it's going to form a basic solution. And if you're coming again from a strong base, just like the strong acid, well, it's going to form a weaker conjugate acid. And so therefore, again, it's not going to react with water and it's going to be neutral. And then finally, if your ion comes from a weak base, that ion is going to be a stronger conjugate acid. And so it's going to be reacting with water in order to give away its proton. And therefore, it's going to create an acidic solution because the ion is acting like an acid. Okay, so you want to look at those things. So let's continue with the steps. I still got more steps, so hold on tight. Okay, so step 4. Figure out what the combination of each ion's contribution would be to the solution. So you figure out which one of the what contribution or what effect each ion is going to have. Is it going to be acidic? Is it basic? Is it neutral? And then you take the two ions and you say, okay, what will be the ultimate result of the solution from both ions together? So if you have one ion that's acidic and the other one neutral, then you're going to end up with an acidic solution. That's going to make the solution acidic. If you have a one basic ion and one neutral ion, then that combined together is going to give you a basic solution. If both ions are neutral, then of course that's going to give you a neutral solution. But what if you have one acidic ion and one basic ion? Well, in that case, you're going to have to compare the Ka and the Kb values of each of those ions to determine which ion wins. So that brings us to step 5. In order to determine the winner of the acidic, or when you have acidic plus basic ions together, well, you're going to compare the Ka and the Kb values, and then the higher K value means that is a stronger acid or base, which means that it's going to dissociate or ionize more and it's going to contribute more to the solution. So here, if the Ka value is larger than the Kb, then the acidic ion is going to predominate. If the Ka is less than the Kb, meaning the Kb is now bigger, then the basic is going to be a basic solution because the basic ion is going to predominate. And then if they're equal, then it's going to be a neutral solution. But here's the problem. We aren't usually given the Kas or the Kbs of the conjugates. We're only given the Kas and the Kbs usually of the acids or bases from which the conjugates came. So what do? That's next. Okay, so let's talk about this problem. So what is the problem again? As I just said, the problem is that you rarely have the Ka and Kb of the conjugate acid or bases, which are these ions that we're looking at from the salts. So you usually only have the Ka and the Kb of the acids or bases from which these ions came. So what you need to do is find the Ka and Kb of those conjugates, and this is how you do it. So we know from before that Kw is equal to Ka times Kb. The Ka of the acid multiplied by the Kb of its conjugate base is equal to Kw. So we can use this equation to find what we're looking for. So if you want the Ka of an ion, then you need to get the Kb of the base it came from. If you want the base or the Kb of an ion, then you're going to need to know the Ka of the acid it came from. So here's a practice problem to kind of make this clear. So what if you're asked, what is the Ka value of NH4 plus? Now, NH4 plus is an ion that we've seen before. So NH4 plus could be part of ammonium hydroxide, right? Or ammonium chloride. So that is an ion. So this is the weak acid. It's a conjugate acid of a weak base. So we would need to find the weak base, the Kb of that weak base. So here is the reaction from which we get the NH4 plus. So ammonia reacts with water, takes a hydrogen from water, and forms the NH4 plus the hydroxide. And here we see that the NH4 plus, the ammonium, is the conjugate acid of this base. Now, because this is the conjugate acid, we're not able to really look up in a table what this is, but we can look this up in a table. So if we look this up in the table, we can find the Kb for NH3. So the Kb for NH3 is 1.8 times 10 to the negative 5. So if we want the Ka of our conjugate acid, we use this equation. So Kw we should know is 1.0 times 10 to the negative 14. So we plug that into our equation. 1.0 times 10 to the negative 14 is equal to the Ka of our conjugate acid multiplied by the Kb of the base that it came from. And then we calculate and we get the Ka is equal to 5.56 times 10 to the negative 10. So that is how you find the Ka of this conjugate this conjugate acid. So that's all I have for this video. I hope this was helpful. If you enjoyed this video, if you learned a lot from this video, if this cleared anything up for you, then by all means, please like the video, hit that like button, smash that like button, share this with your friends, subscribe to my channel, make sure you hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me and have a great day.